Good afternoon. We will discuss this strength evaluation because I believe I should also learn the how to evaluate the strength of the existing concrete structures as per NECP 2015 section 4 to 7. So this is actually from the slide of, the presentation of Engineer Jerry B. Baratas of GEMAR Engineering Services. So the flow of the topic, the slides, first is we have the introduction, a little bit of introduction, the scope of section 4 to 7 of NECP 2015, the analytical strength evaluation, through verification of as-built condition, strength reduction factors, strength evaluation of load test arrangement and load factors, test load application, response measurements, acceptance criteria, and reduce load rating. So even with old buildings and with a new, not in example, the school buildings should comply with the NECP 2015 section 4 to 7 in evaluating the strength of concrete structures. So the section 47.1, these provisions of this section shall apply to the strength evaluation of existing structures by analytical means or by load testing. So what are the difference of this analytical means or by load testing? In general, if there is a doubt that a part of or all of a structure meets the safety requirements of this code and the structure is to remain in service, a strength evaluation shall be carried out as required by the licensed design professional or building official. Yes. As per as stated in this section, if there is a doubt that the structure meets the safety requirements, so it should be the decision of the licensed professional how he will carry out the strength evaluation through analytical means or by load testing. So if in section 47.2.2, if the effect of the strength deficiency is well understood and if it is practical to measure the dimensions and determine the material properties of the members required for analysis, an analytical evaluation of strength based on this information is permitted. Required data shall be determined in accordance with section 47.3. Meaning, if there is the strength efficiency is well understood, you can use some softwares that will evaluate the strength. An analytical evaluation is through simulation of the building. So from the as-built plan, required data shall be determined in accordance with section 47.3. This is through the as-built plans. So you will model the structure, then simulate so that you can evaluate the strength. This is the analytical evaluation of structure. 427.2.3, if the effect of the strength deficiency is not well understood or it is not practical to measure the dimensions and determine the material properties of the members required for analysis, a load test shall be required in accordance with section 437.4. So, kung ang strength deficiency is not well understood, this time you have to use the load test in accordance with this section, no? Right. If uncertainty about the strength of part or all of a structure involves deterioration, and if the observed response during the load test satisfies the acceptance criteria in section 427.4.5, the structure or part of the structure is permitted to remain in service for a time period specified by the licensed design professional. If deemed necessary by the licensed design professional, periodic re-evaluation shall be conducted. So, yes, if there is uncertainty about the strength, dili ka sure sa strength, because nag-involve na siya og deterioration of part of the structure or all, no, of the structure. So, according to section, the evaluation or the acceptance criteria should satisfy the section 47.4.5 of the NEC 2015 and will be permitted to remain in service. Depende sa decision, no, as deemed necessary by the licensed professional structural engineer, no, depende sa iyang evaluations. Then kung kailangan og re-evaluation, then re-evaluation of the structure shall be conducted. This is the this as-built condition, no, verification as of as-built condition of the plan, no, as-built condition of the existing structure. This should be used to verify, this should be used in the analytical strength evaluation. It can be the existing structure, no, condition can be used to model in the software, then simulate the behavior of the structure for analytical strength evaluation. Dimensions of members shall be established at critical sections, no, for the analytical strength evaluation. So, na kay as-built nga plan or as-built condition of existing structure, can determine here sa as-built condition, as-built niya nga plan, those critical sections. Now, the critical sections is actually the connection between the connection of the beams and the columns. Itong joint sa connection sa beams and columns, those are the critical sections. So, those part or those sections should be evaluated. Locations and sizes of reinforcement shall be determined by measurement. It shall be permitted to base reinforcement locations on available drawings if field verified at representative locations to confirm the information on the drawing. So you have the as-built condition of the existing structures, then you will base the reinforcement location on the as-built plan, no, of the existing structure. Then, if required, an estimated equivalent compressive strength shall be based on analysis of results of cylinder test from the original construction or test cores removed from the part of the structure where strength is in question, no. Your strength evaluation, you can based on the results of the cylinder test, no, its compressive strength, or you can through coring, no, you can remove part of the structure through cores, no, test of cores. So mag-drill kag core dito, then if the strength is in question, no, mag-drill kag cores dito, then test the cores. The method for obtaining and testing cores shall be in accordance with ASTM C42M, the standard test method for obtaining and testing drilled cores and sawed beams of concrete, no. So just like the in the PCCP, no, Portland cement, concrete pavement. Then if the structure is in question, testing of course, no, or part of the PCCP, you have to drill course, then test the course, no, if the strength is in question. For the reinforcement, reinforcing steel, the properties of reinforcement are permitted to be based on tensile test of representative samples of the material in the structure. So you have to test also the reinforcement of the structure through tensile test. Now you can just get now representative of the samples, then test. We have this term, no, the strength reduction factors. If dimension, size, and location of reinforcement and material properties are determined in accordance with section 427.3.1, it is permitted to increase the strength reduction factors from the design values elsewhere in this code. However, the strength reduction factors shall not exceed the limits in table 427.3.2.1. So we have the list of the phi, no, or the strength reduction factors. So this one, this is, or these are the maximum permissible strength reduction factors. So if the structure, member structure is for flexure axial, so the maximum permissible reduction factor is 1.0. So these strength reduction factors, these are used to decrease, no, the estimated strength of structural members. So example, you have the design, no? Before constructing the building, you design the building as that strength, iyang capacity. Then over time, after how many years, you evaluate the strength. Then that strength reduction factors, you can limit the factors based on this table not to exceed this one, so that the strength of the, you can redesign the structure, and ang capacity niya pwede siya reduce. You can estimate, no, through reducing the strength reduction factors, pero dapat dili siya mo limit lang siya ani nga values. We have also in 427.4.1 natin itawag nga load test. Now, load test shall be conducted in a manner that provides for safety of life and the structure during the test. Safety measure shall not interfere with the load test or affect the result. So during load test, ang safety measure, so dapat dili siya mo load test should not interfere, no, with safety measure of the structure. So, according to 47.4.1.3, the portion of the structure subject to the test load shall be at least 56 days old. If the owner of the structure, the contractor, licensed design professional, and all other involved parties agree, shall be permitted to perform the load test at an earlier age. So, the load test actually I posted in the Google Classroom, the video for the load test for you to familiarize or to know how to do the load test. So this is a provision for a precast member to be composite with cast in place concrete shall be permitted to be tested in flexure as a precast member alone in accordance with A and B. So test loads shall be applied only when calculations indicate the isolated precast member will not fail by compression or buckling. And the test load when applied to the precast member alone shall induce the same total force in the tensile reinforcement as would be produced by loading the composite member with the test load in accordance with section 47.4.2. So testing the precast member in flexure, so dapat siya comply aning A and B. So kung i-test lang daw nimo ang precast member alone, should not fail compression or buckling, and shall induce the same total force in the tensile reinforcement, the same total force kung loadan nimo ang precast member with its composite member, katong cast in place member. This is the test load arrangement and load factors. So test load arrangement shall be selected to maximize the deflection, load effects, and stress in the critical regions of members being evaluated. So you put the test load, the load, no? Or you arrange the loadings so that the beam or the structure will give the maximum deflection and stress. Now, in this example, in this figure, there is this beam, no? And there are loadings at the center, no? Actually, almost, no, at the center. So that because the center will give the maximum moment or maximum deflection. This is the total test load, including dead load already in place, shall be at least greatest of A, B, and C. So you have this equation or formula of total test load. So the greatest of the three, this will give, no, the test load that we will be using in the strength evaluation. It is permitted to reduce live load or L in section 427.4.2 in accordance with the general building code. So the load factor on the live load in section 427.4.2.2b shall be permitted to reduce to 0.45 except for parking structures, areas occupied as place of public assembly, or areas where L is greater than 4.8 kPa. In the formula earlier, there is total test load. For example, in A, 1.15 dead load plus 1.5 live load plus 0.4 roof live load or rain load we can reduce the live load, no, to 0.5, except for these parking areas occupied as place of public assembly or areas where L is greater than 4.8 kPa, no. So except aning structure, we can reduce the live load using this relation. So for the test load application, the total test load shall be applied in at least for approximately equal increments. So this figure here, these are actually the material na imong i-load, no, to the member kung asa imong gusto kuan of evaluation. Then uniform test load shall be applied in a manner that ensures uniform distribution of the load transmitted to the structure or portion of the structure being tested. Arcing of the test load shall be avoided. So during the test load, no, there should be, or the test load should be applied at least 4 equal increments, no. And after the final load increment is applied, the total test load shall remain on the structure for at least 24 hours unless signs of distress as noted in section 427.4.5 are observed. After all response measurements are recorded, the test load shall be removed as soon as practical. Then for the response measurements shall such as deflection. Now if there is deflection after the load test, strain, slip, and crack width shall be made at locations where maximum response is expected, no, as what earlier slide, no, in the earlier slides. So you put the test load that will give the maximum, example, deflection or maximum moment, no, where the maximum response is expected. Additional measurements shall be made if required. The initial value for all applicable response measurements shall be obtained not more than 1 hour before applying the first load increment. A set of response measurements shall be recorded after each load increment is applied. So you gather data, you take note of the response measurements after each increment, no, after each equal 4 increment is applied, and after the total test load has been applied in the structure for at least 24 hours. So this is the instrument, no, used to measure the response of the structure or member during the test load. A set of final response measurements shall be made 24 hours after total test load is removed. For acceptance criteria, the portion of the structure tested shall show no spalling or crushing of concrete, no, or other evidence of failure for acceptance criteria. So there should be no spalling or crashing during the after the application of the test load. Members tested shall not exhibit cracks indicating imminent shear failure. So the diagonal cracks, no, if there are diagonal cracks, meaning that shows the shear cracking or shear failure. So members after testing or after the application of test load shall not exhibit those kind of cracks, shear failure. In regions of members without transverse reinforcement, structural cracks inclined to the longitudinal cracks and having a horizontal projection greater than the depth of the member shall be evaluated. For variable depth members, the depth shall be measured to mid-length of the crack. So in regions with a transverse reinforcement, so katong region na you have the longitudinal reinforcement sa beam, di ba? So between kung na ay inclined or diagonal cracks, it should be evaluated. So if there are structural cracks inclined to the longitudinal axis and having a horizontal projection greater than the depth of the member, okay, ingani ni siya, nagdiraw na lang ito, no? So let us try to understand, no, the sabot pa sabot ani, so after evaluation or after testing, no, so for example, this is the transverse reinforcement of the beam, di ba, or the stirrups. Say this is the beam, I mean this is the longitudinal reinforcement. This is the beam, no, this is the beam, kana siya. If there is structural cracks niya, nag-incline siya, so example diagonal, no, members without transverse reinforcement, so between this member, I mean between this region here, so kung naa kay diagonal cracks, example this one, so the horizontal projection of that crack should not exceed, no, than the depth of the member. Horizontal projection of this crack, example this horizontal projection, kana siya, dapat this horizontal projection of the crack should not exceed the depth of the member, of this member, of this member beam, which is the H. Kung gabari ang depth sa members, ang depth, no, shall be measured at the mid-length of the crack. In regions of anchorage and lap splices of reinforcement, short inclined cracks or horizontal cracks along the line of reinforcement shall be evaluated. This is the strength evaluation by load test using the deflections, no. The measured deflections shall satisfy A or B. So the first deflection should be less than or equal to this total length square divided by 20,000 H. This is the length of the member divided by 20,000, the height of the member. Then delta R, or this is the still deflection, no, in letter B, should be less than or equal to the first deflection divided by 4. So if this satisfies, then the member or the structure is fine. Then if section 47.4.5 is not satisfied, or those two deflections, no, it shall be permitted to repeat the load test provided that the second load test begins no earlier than 72 hours after removal of externally applied loads from the first load test. Then portions of the structure tested in the second load test shall be considered acceptable if the deflection is less than or equal to the second deflection divided by 5. The second deflection, still the same formula, is the total length of the structure square divided by 20,000 times the height of the structure. If the structure under investigation does not satisfy conditions or criteria of section 47.3 analytical evaluation by load test or 427.4.5 acceptance criteria, the structure shall be permitted for use at lower load rating, no, based on the results of the load test or analysis if approved by the building official. So based on the load of the test or analysis, no, then wala siya ni-satisfy sa section 427.3, which is the analytical evaluation, and also kaning 427.4.5 in the acceptance criteria above, no, or earlier, then depende if approved by the building official, can be permitted to for use at lower load rating, no. You can redesign the building, not but I mean redesign the building that will hold no minimum capacity of load. No, you can determine no, the maximum, the maximum load nga reduce na siya, no, pila ang load lang niya ma-carry after doing the analytical evaluation by load test, after doing those provision, no, in the strength evaluation. That's all, and thank you.